Okay, now we're looking at least 3 are wireless only. So at least 3, that can start at 3 and go all the way up to 20. And it's 20 because we are looking at 20 houses. So that's the max right there. I have 18 different numbers between 3 and 20. So that means I would have to use this formula right here 18 different times and then add all of my results together. But there's an easier way of doing this. So from 3 all the way up to 20, that is at least 3. Possible values are 0, 1, and 2. Now this is at most 3. So what we're trying to do is we're trying to find the probability of at least 3. So if I take the probability of both at most 3 and add it to at least 3, okay, then that's going to give me all these numbers from 0 all the way up to 20. And if I find the probability of each and every one of those from 0 to 20 and then add all of them up, well, since I'm adding everything up, this should be equal to 1. Now what I'm trying to find is at least 3. So I'm going to subtract at most 3 from both sides. Okay, now at most 3 will cancel out, and I'm left with the probability of at least 3 is equal to 1 minus the probability of at most 3. Now we found the probability of at most 3, see right here, fewer than 3 or at most 3. See, you've got the 0, the 1, or the 2. We found that to be 0.0912. Now I'm going to take that answer and plug it in over here. So this is going to be equal to 1 minus 0. Let's see, what was it? 0912. 0912. Now this will give me 0.9088, and this will be my final answer to the probability of at least 3 are wireless only. Okay, the number of households that are wireless only is between 5 and 7. So the probability is between 5 and 7, so this is 5 and 7. So notice that x is between these two numbers. Okay, so really, this is just the probability of 5 or 6 or 7. Remember, an OR probability, you're going to add, so probability of 5 plus the probability of 6 plus the probability of 7. So I'll need to use this formula 3 different times and add them all together. So this is going to be 20, because we're still looking at 20 houses max. Combinations 5, and then it's going to be probability of success, which is still 0.25 raised to 5. Probability of failure, 0.75 raised to 20 minus 5. Plus, okay, that was just 5 right there, this part right here. Now moving on to 6. So this is going to be 20. Combination 6, 0.25 raised to 6, 0.75 raised to 20 minus 6, plus 20, combination 7, 0.25 raised to 7, 0.75 raised to 20 minus 7. Okay, now I've got all 3. And I'm just going to clean this up just a little bit by taking the 20 minus 5, 20 minus 6, and 20 minus 7. And just, it should look like this right here. So for this first combinations, what you should get is 0.2023. For this second one, so plus, you should get 0.1686 plus, and for this last one, you should get 0.1124. Now you're going to add all of these together to get 0.4833 as your final answer. Now you can enter this entire thing into your calculator, or you can take it a bit at a time and get each individual answer here and then add it all up. It will come out the same way. So this is like saying about 48% chance. That's the probability that the number of wireless-only households will be between 5 and 7. You draw 7 cards with replacement. You win the game if you get at least 5 hearts. What's the probability of drawing at least 5 hearts? Or basically, what's the probability of winning? So our N is going to be 7, because you're drawing 7 cards here. Probability of success, or P, would be drawing a heart. Okay, so how many hearts do you have in a standard deck? Well, you've got 13 hearts out of 52 cards. Okay, how many cards are not hearts? Well, first off, 52 minus the 13 cards that are hearts, that's going to leave you with 39 cards that are not hearts. So 39 out of 52 cards are not hearts. And then what are all the possible values that X could be? So it says at least 5. So that could be 5 hearts, or 6 hearts, or 7 hearts. Notice that I have to stop at 7 because that is my max card. I'm only drawing 7 cards here. Okay, so then I'm probably looking for the probability of at least 5. So at least 5 hearts. So we just said that this could be a 5, or 6, or a 7. Which again, this is an OR probability, so we're going to add this. So the probability of 5 plus the probability of 6 plus the probability of 7. So we'll be using this formula 3 times again. So for this case, this is going to be 7 combinations 5. I'm doing the first one. And then notice that this is 0.25. This is 0.75. So 0.25 raised to 5 times 0.75 raised to 7 minus 5 plus, 6. 7 combination 6, 0.25 raised to 6, 0.75 raised to 7 minus 6. And then last one, 7 combination 7, 0.25 raised to 7, 0.75 raised to 7 minus 7. And then clean it up just a little bit. It'll look like this. Now notice I changed the 7 minus 5 to a 2, the 7 minus 6 to a 1, and since it's just 1, I don't put anything here. A 1's understood. 7 combination 7. Anytime you have the same number in both spots, that's going to be a 1. And the 7 minus 7 is a 0, and anything raised to 0 is also 1. So all I'm left with is the 0.25 raised to 7. Okay, now when I plug this into my computer, or not my computer, my calculator, for the first one I'm going to get 0.0115. For the second one I'm going to get 0.0013. And for the last one I'm going to get 0.0001. Now when I add all of this up, my final answer is going to be 0.0129. So that's the probability that you'll win this game right here, or the probability of drawing at least 5 hearts. Now if you change this to a percentage, move this over twice, it's about a 1.3% chance. Okay, now there is another way to do these things. We have something called a binomial table, where somebody has already computed each one of these binomial probabilities. Here's the table. So all of this up here, this is going to be your probability of success, and they've got that denoting P right here. Okay, for your max number or your N, that's going to be these first numbers here. Okay, these first numbers right here. And if you kept going all the way down, notice that this goes from 2 all the way down to 15. Okay, so the max number is 15. Now to the side of that, notice if your max number is 2, it's always going to start at 0 and go to this max number. So it went from 0 to 2. And then say for 6, it went from 0 up to 6. Okay, so if you were looking for, well, let me just show you an example here. According to the Gallup organization, 60% of adult Americans are in favor of the death penalty for individuals convicted of murder. In a random sample of 15 adult Americans, what's the probability that A, exactly 10 favor the death penalty? Okay, so my N is 15. The probability that we're looking for is people who are in favor. So this would be 0.60. Get this out of percentage. And our x value that we're looking for is exactly 10. So x is equal to exactly 10. And then we'll go to our table. Our p-value is 60. So I am in this column right here. Okay, but notice what's my n? It was 15. So we need to scoot down. Okay, there's 15 right there. Okay, so my p-values are still at 0.60. So I'm somewhere in this little section right here. Let's go down a little bit. Okay, now here's all of our x values right here. And we were looking for exactly 10. Okay, so that means I'm in this row right here. Now where they overlap, this right here, and you can't see that point sign, but it's 180. Get rid of that. It's actually 186, not 180. That is our answer right there, and that's all we need. So therefore, the probability of getting exactly 10 people who favor, this would be equal to 0.186, and you're done. Okay, now if it says 10 or 11, remember the or is going to be addition. It's the addition rule. So probability of 10 or 11 is the probability of 10 plus the probability of 11. We just found the probability of 10. That was 0.186. But now I got to go back and find 11. Okay, so we found 10 was, here's 10 right here. There's 10. And we need 11 right below it. There's 11. 0.127. All right, plus 0.127. Add those two up, and you get 0.313. And that would be your final answer. And no more than 6. So the probability, no more than 6, that's going to be x is less than or equal to 6. So this could be 0 or 1 or 2 or 3 or 4 or 5 or 6. So we need to find the number for each one of these, for the 0, for the 1, for the 2, 3, 4, 5, and 6, and then add them all up. I'm still working with n is 15, and I'm still working with a p-value of 0.6. I'm still in this column right here. Okay, so I'm looking at 0 through 6. So I need this one, this one, this one, this one, this one, this one, and this one right here. Notice this 0 and a plus mark. Notice this little note down here. It represents a positive probability less than 0.0005. So we're going to treat it, since it's so small, we're going to treat it as though it's 0. So I'm only going to take this 0.22 or 0.002, 0.007, 0.024, and 0.061 and add all those up, and that will give me my final answer. Okay, now I'm going to add all this up, and this will give me 0.094, and that will be my final answer. See, somebody has already created that table, so we didn't have to use that formula see, 1, 2, 3, 4, 5, 6, 7 times. Okay.